Today we are going to look at a projectile problem in the Cambridge admission test. We will see how a simple projectile problem slowly becomes a trigonometry problem. This question was quoted from the 6th term examination paper from 2017. A particle is projected at speed u from a point O on a horizontal plane. It passes through a fixed point P which is at a horizontal distance d from O and at a height d tangent beta above the plane, where d is greater than 0 and beta is an acute angle. The angle of projection alpha is chosen so that u is as small as possible. First, show that u squared is equal to g d tangent alpha and 2 alpha is equal to beta plus 90 degrees. Also, at what angle to the horizontal is the particle traveling when it passes through P? Express your answer in terms of alpha in its simplest form. Even though it might seem hard to find an approach to start with, but as with other projectile question, it is a good practice to start with a sketch. We have a particle projected at an angle alpha with initial velocity u. And the point P is defined as horizontal distance d and vertical distance d tangent beta. After sketching the diagram, we can now consider the horizontal component and vertical component respectively. For horizontal component, we have displacement d, initial velocity u cosine alpha, acceleration 0. With this information, we are able to find an expression for time by using a Suvat equation. For vertical motion, we have displacement d tangent beta, initial velocity u sine alpha, acceleration negative g and time from above. Substituting into the same Suvat equation, and then rearranging it, we get an expression for u squared. Since we are required to express u squared in terms of g, d and tangent alpha only, we need to find an expression for tangent beta. In fact, we are going to find an expression for tangent alpha minus tangent beta. Since alpha is chosen such that u is as small as possible, this means that du by d alpha is 0. By the chain rule, we have this. We simplify this expression by making secant squared alpha as numerator to make life easier for quotient rule. Using the quotient rule and simplifying this gives us this expression. Remember that this expression is equal to 0 due to the minimal selection of alpha for u. We can deduce that secant alpha squared is equal to 0 or the later expression is equal to 0. By definition, secant alpha is the reciprocal of cosine alpha, and a reciprocal cannot be a 0. So must have the later expression being 0. Move the secant alpha squared to the right-hand side and take out common factor on the left-hand side, we get an expression for tangent alpha minus tangent beta. Now substitute back to u squared, and we get the first required result. We continue with the expression for tangent alpha minus tangent beta. Rearranging and simplifying gives tangent beta equals to tangent alpha squared minus 1 all over 2 tangent alpha. Notice that this is nearly identical to the reciprocal of tangent 2 alpha. In fact, tangent beta is the negative of cotangent 2 alpha. Expand cotangent and consider the complementary angle. We have tangent beta equals to minus tangent 90 degree minus 2 alpha. Since tangent alpha is an odd function, this means that minus tangent alpha is equal to tangent minus alpha. Hence we have beta equals to 2 alpha minus 90 plus repeating solutions for every 180 degrees. Since alpha is acute and alpha is greater than beta, we must choose k equals to 1. Hence beta is equal to 2 alpha plus 90 degrees as required. For the second part, to find the angle, we need to compute the final velocity for both horizontal and vertical component. For horizontal component, the final velocity is u cosine alpha as well because there is no acceleration in horizontal motion. For vertical component, we have initial velocity u sine alpha, acceleration minus g, time d over u cosine alpha. Using this information, we get an expression for vertical component for final velocity. Say the angle to horizontal is sigma, then we have tangent sigma equals to the vertical component over horizontal component. Tidying up the expression, we get tangent alpha tangent sigma equals to -1. This means that tangent sigma is equal to minus cotangent alpha. Following similar approach from above, we get that sigma is equal to alpha minus 90 plus 180k. Since sigma is below horizontal, we must choose k equals to 0. In other words, sigma equals to alpha minus 90. This is only one of the ways to solve the problem, in my own way. For example, if you compare to the marking scheme, you would see that they did not put secant alpha squared to the numerator for the differentiation process. Furthermore, they quote the result of negative cotangent alpha is a transformation of tangent alpha. I think it is not common to visualize it at the first instance. At least this was not something I have been taught in A-level mathematics. Remember, some knowledge that you deem fundamental might not be usual to others. I am not saying that you should justify or prove every result that you quote in an answer, but you should be able to do it in your mind. Thank you for watching this video. If you have any insights and more ideas to the problem or solution, feel free to comment below. I will see you next time.